So this again, so as we discussed last video, when you have one type of customer with one risk profile, right, with one probability they get sick, the Rothschild-Stiglitz models predicts that there will be an equilibrium, and it will be the best, the only equilibrium point is the equilibrium point that is best for the consumer, right? It's a full and actuarially fair insurance, right? So omega is on the full insurance line, it's on the zero profit line. Being on the full insurance line means it's full insurance, and being on the zero profit line means it's actuarially fair insurance, right? So this is great news, right? We can all celebrate, we can rejoice. Things are great, right? But what happens if we account for, what if there are different risk profiles? So let's go through the case where there are two risk profiles. There are frail people. So there are people who are frail and people who are healthy, right? So PF, let's do fancy script F. So we have PF equals prob frail person gets sick. And then we have PR is the prob robust person gets sick, right? So there are two types of people. There are frail people who are likely to get sick. And then there are robust people who are unlikely to get sick, right? So PR is less than PF, right? So and then we also have if you have PR and PF, we also have a market-wide probability of falling slip, which is P average, which is average prob of falling sick, of getting sick. In overall market, right? So this is the probability that somebody within a market gets sick, right, is P average, right? So individuals know whether they are robust or frail, and we're going to assume that the insurance company does not know whether they are robust, or, well, we will consider what happens if the insurance company knows they're robust versus frail, and we will also consider what happens if the insurance company does not know whether they are robust or frail, right? So before we do that, though, let's consider the different profit lines, zero profit lines, for the different populations, now that we've allowed for there to be sick and healthy people, right? So we have, as always, our income when sick on the y-axis, income when healthy on the x-axis. We have our full insurance line, right? I'm assuming we don't need that labeled anymore. And we still have our point of what we get if we don't buy insurance, which is, as always, E, right? But now there are several different lines to consider. So there is the zero profit line for the robust people, which we'll say is this. And then there's going to be the zero profit line for the frail people, which we'll say is this. And then there's going to be the zero profit line for the total population, which is going to be somewhere like this, right? So if I label these, right? So this is robust type, zero profit line. This is frail type. Zero profit line. And then this right here is the population. So the population zero profit line is if you could force everyone in the population to accept a contract, profits on the zero profit on the population zero profit line would yield zero profit. So this is how the different types of this is a robust type zero profit line will be steeper than a frail type zero profit line, and that's because the odds that a robust type person is lower, and so then the odds that a frail type. So you can offer them more generous insurance, right? So I can offer, right, let's consider the case of full insurance. If somebody's unlikely to be sick, I can offer them a pretty generous policy. But if they're very likely to be sick, I can't offer them a generous policy. Otherwise, I'll go out of business if I do that too much, right? So that's why the robust type zero profit line is steeper, because at any given you can pay them more, right? You can give them more when they're sick, and take less when they're healthy, because they're more likely to be healthy and less likely to be sick if you're an insurance company. And again, the population zero profit line is if you could force everybody to buy a contract, the population zero profit line is actuarially fair for the total population. Note that it's unfair for robust types and more than fair for frail types. So the population zero profit line, if as I'm describing it, you're saying, hey, that sounds kind of useless, hold on. But wait, there's more. And you're onto something. The other thing that I want to consider before we go into discussing sort of how the presence of two different types of consumers, frail and robust consumers, affects the equilibrium for insurance markets. Let's go over the different indifference curves for the robust and the frail. So let's do 3 contracts. Let's do or 2 contracts. Let's do the contract for frail here, contract for robust here, and then we'll do E is down here, right? Right. And let me put E down here. So it turns out that the indifference curves, for the same reason that the profit lines are steeper for robust people, their indifference curves are also steeper, right? So if I draw 2 indifference curves, let's just go ahead and do both green, right? So, right? So this is UR, right? That's the robust type indifference curve. And then let's go ahead and make this dashed, just to keep the notation consistent, where dark green is sort of the initial indifference curve you're on. I do not need to make the labeling dashed, though. And this is UF, right? So the contracts I just drew, right, CR and CF, are they're 2 contracts that they're contracts on for a certain income, right? They get the same amount, right? CR and CF, right? They gain the same amount of steady state income X, right? So let me go ahead and do a few more lines here. Hold on, we'll do dotted. So go like and then we'll have, let me erase a little bit off the end, and then let's go back here and continue this line down, and then we'll continue this line down, and then we'll continue this line down, and then we'll go back to this, to solid black, and then right? So in both these contracts, right, the person gets X dollars in the steady state, right? And so this is healthy payoff when frail. This is healthy payoff, income in the healthy state for the robust person. And this is under the contract. And then this is the healthy payoff if they get nothing, right? And then this is going to be SF. Hold on. This right here is SF equals SE, right? And then, SR. And then down here is SE, right? So these CF and CR are how much they're the contracts that are the same on the indifference curve if they get, so if I want to compensate, right? So these are two different contracts, right? That offer the same money in the same amount of money in the sick state, and you'll notice that in order to get to the frail person is willing to give up much more income in the healthy state than the robust person will be, because the frail person is much more likely to get sick, right? So if you're more likely to get sick, you want to be insured against the sick state more because you're more likely to end up in it. And so as a result of this, right, the robust indifference curves are always steeper than the frail indifference curves, right? And so, and you can show, by the way, that if you choose to do a PhD or an advanced master's, you can show that these indifference curves will, any pair of indifference curves for the frail and robust types will only ever cross once. This is called the single crossing property, and it's important in certain proofs. You don't need to know it. So now that we've covered indifference curves and the zero profit lines, let's combine these, right? So what happens when we have these indifference curves and these zero profit lines together? And we have income when sick, as always, on the y-axis, right? Then we have income when healthy on the x-axis. All right, let's go ahead, do our full insurance line, right? That's good old full insurance line, right? It's always the same. Then let's go, and just to be consistent across time, right? So we'll do point E, right? So point E is going to be like here or something, right? This is point E. And then we'll have our robust type zero profit line, our sick type, our frail type zero profit line, maybe sickly or frail. Right, they're not sick yet, but they might get sick. And then we have our, admittedly, we will show why this is somewhat useless. And let me do this in dotted just to be consistent with the previous graph. Population zero profit line. And then if I draw the two indifference curves, right? So let's go dark green, right? So the indifference curves for, I'm going to draw two different indifference curves. Actually, no, neither of them is going to be dark green. I'm going to use orange because they're both going to be better. But I'm going to do frail is going to be a dashed line. So to go starting here, it's going to go right, and so that's going to be UF. And then for the solid indifference curve, which is going to represent the robust type, it's going to look like this. And that's let's do that a little better, right? It's going to be UR, right? Okay, so now we have I've drawn, right, what are these indifference curves in particular? These are the indifference curves for the frail type that is indifferent at sort of what the frail type's optimal fair contract would be, and the indifference curves for the robust type at what the robust type's optimal fair contract would be, right? So now that we have these indifference curves, we can think about what's going to happen when we try to form an equilibrium?